All right. That's a little embarrassing. Um, thank you, Jasmine. All right, guys, I was muted. What I'm saying right now is this. I want to do a couple of things. We're going to start off this lecture by going back over 5.2. If you look at the syllabus this semester has us looking at 9.1 today and then 9.1 tomorrow. But Monday was rather unique. Monday, we did not meet class, but all of you were expected to watch the recorded reading of 5.2, do the homework, not the homework, the math exam, and do the handout, right? You have a week still to do it, and then answer the detailed notes. So I just want to make sure before we move on to 9.1, when you guys were doing those activities for 5.2, do you have any questions or concerns that you would like to be addressed?
On the syllabus or on DCLL, it says 9.2. Does it say 9.1?
Oh. Let me do share screen. All right, so looking at this right here. Oh no, hold on. You got to remember what day it is. You're a little fast, Jasmine. You in the future. 9.2 is next week, right? The syllabus that we have up there today, which is Wednesday the 10th, and then also Friday, we'll be looking at 9.1. So we'll be spending 2 days on it. You had me real scared.
No, I don't see it on D2L.
On D2L?
Yeah, like on the content page.
On the content page. All right, let's look at so let's go right here for stats. Okay, and you know what that is? That is because I don't have the 9.1 folder in here and created yet. However, and this is actually a good point. I hope you guys weren't lost on this. But the recording, if you go down to the recorded lectures, you go into stats 2, and then you go on to the recorded lectures, which is the first folder under there. The 9.1 lecture is there. But you're absolutely right. I need to create a folder for reading 9.1 to put it in there. But the recorded readings aren't usually there. And I will create and add into that 9.1 folder the math exam. I'll add in there the handout quiz, and then also the handout for you guys to look at. So yeah, I apologize for that. I see what you're saying. All right, and again, guys, I want you guys to know that even when this is being said and done, this is very key. I want to make sure that you guys are reaching out to me. If something is like this and you guys notice it, please let me know. Please let me know. I am not against fixing anything or even admitting that I don't have something right. Let's see, stats 2. I'm going to make a folder right now. All right, but still, let's go back to what I mentioned before. Is there anybody that has any questions from 5.1 that they would like to see addressed and or answered? Okay, now, so without that being an issue, I think everybody knows what we.
Wait, no.
All right,
no,
go
sorry.
ahead. Go ahead.
Thank you. Can you do your little, Dr. Barnes definition for the binomial probability distribution?
Yeah,
like
okay.
your little spin on that.
I actually, you're a little different because you think that the Dr. Barnes definition is better than the textbook, but I'll definitely give it to you by popular demand. All right, so
Thank you.
I'll go into this. Let me see if I can get in the textbook, right? Let's go to 9.1. And let's see what the definition is. And I'm going to put you on the spot because since you went to Dr. Barnes' definition, I think you know what the I don't even see. Oh,
No, I'm talking about 5.2.
Exactly.
Wait.
Yeah, I'm trying to be fast. Okay, so I'm going to rely on you to give us the textbook definition of this, and then I'll try to I don't know, Dr. Barnes it. All right, so let's blow this up a little bit. Now, Reese, so reading this definition, if you don't mind, read this definition or give me a synopsis of what you think your takeaway from it was.
A binomial probability distribution results from a procedure that meets these 4 requirements. Is that, yeah. The procedure has a fixed number of trials. The trials must be independent, meaning that the outcome of any individual trial doesn't affect the probability in any other trials. Each trial must have all outcomes classified into exactly 2 categories, commonly referred to such as success and failure. And last, the probability of a success remains the same as in all trials.
Okay, now that's what we have on paper. And you know what? I think I'm saying this, I can definitely understand how this can be confusing. And the reason why is because, yeah, I don't actually know why it can be confusing. I don't know why they define it this way. But this is telling you the kind of the characteristics of what a binomial probability distribution is. Now, I'm going to sit back on here and kind of draw what it kind of looks like, right? Binomial probability distribution looks like almost any other distribution, right? But what I'm going to do is this. I'm going to draw a whole bunch of them. And the reason why I'm drawing a whole bunch of them is because depending on the number of fixed trials, the shape changes. The shape changes. And there's a unique binomial probability distribution for each number of different trials that are being done. So a binomial probability distribution at the simplest level, we know that it is a distribution, right? Now, what we mean by binomial is the fact that it's limited to talking about aspects in which our categories have 2, our outcome only has 2 possible outcomes, either success or failure, right? So we're going to sit back and say, we're going to say success is passing. Ooh, we're going to say passing a class. Right? And then the other option would be fail. Right? So that's just it. There's no in between. You either pass or you fail. Now you might sit back and be like, Dr. Barnes, I'm not happy with my grade. I don't care if you're not happy with your grade. Did you pass or did you fail? Dr. Barnes, I think I want to take the course over because I didn't learn anything. I don't care if you didn't learn anything. Did you pass or did you fail? That's the way that the binomial probability has to look at certain things. You might sit back and argue that the instructor didn't know how to teach. Dr. Barnes don't know what he's doing in this class. I don't care if he doesn't know how to teach. What we're talking about right here is you got to put you into these 2 categories, no gray area. You either pass or you fail. And honestly, when I just said this, I started to realize that there is another option because I just seen it just recently. You might get a pass or you might get a fail or you might get an incomplete. And some of y'all might be talking about like, well, Dr. Barnes, technically our grades are A, B, C, D, and F, right? True. But an A, a B, and a C, and a D are passing. So it gets rid of that gray area. And of course, the F is fail. And essentially an incomplete will end up being a fail as well. So actually, I don't think there is any exception to the rule. Pass and or fail, right? Now, the procedure has to have a fixed number of trials, and that's why we have different colors. And now I'm going to go back to the back of the book and kind of show you these. Thank you so much, Narees, for getting me into a situation where I'm scared I'm going to mess up.
You're welcome. You do that all the time for me.
Yeah, let me see. So looking at this, I want you guys to sit back and think about that binomial probability because it has those distributions. I mentioned that each of these tables have their own binomial probability depending on the number of trials. So this right here is N for 2 trials, which means that we are talking about taking a test twice. Let's do that. We're going to do taking a quiz twice. Like the math exams in this class, we actually have, you can take them 5 times, right? The math exams thus far. But let's imagine that I just said you can take it twice, right? So I want you to look at this graph because this graph is really a list of all the binomial probability distributions. What this is saying is this. If you take a test twice, right? And we're going to say that a success is passing it. Look at all the possibilities that could occur. You could take the test twice and you could pass the exam 0 times. Now, I hope this is nobody in this class, but That's a possibility. You take the math exam twice and you pass it 0 times. There's also a possibility that you take the exam twice and you pass it 1 time. There's also the possibility that you take the test twice, take the test twice, and you pass it twice, right? Now, that's kind of what this table looks like. And we can go further, say the same exact thing for everything else. Let's say you can take it, oh, you know what? There's no reason to sit back there and make it seem like we can't have a discussion about 5. If we wanted to, we could do it here. You can take the math exam 5 times, and in that you can pass it 0 times, 1 time, 2 times, 3 times, 4 times, or 5. Trust me, when I look at people's grades, I'll be able to see that, right? Now, the other reason why this binomial probability distribution table, right, is so important, because what we're able to do is this. We're able to sit back and say, all right, I want you guys to think about this. I'm gonna use Jasmine, right? Jasmine, I'm gonna go with Burgess, right? Now, Burgess, I want you to sit back and think about your level of dedication. You've been Cheney for a while. You've been having classes, you've been having exams, right? I want you to probability that you think you are to pass any test I throw your way. It don't matter. If you're in the class, what's your probability that you think you would pass a test?
Like 8 out of 10 times, I guess.
8 out of 10 times. Now, you know what she did, guys? She gave me a fraction, right? Ain't nothing wrong with that fraction, but I asked for a probability. So we're going to take what she gave us and we're going to get to what we need. She said 8 out of 10 times she'll pass a test. So
0.8.
No, slow down. You already talked, Jasmine. You off the hook. You off the hook.
My bad.
So what percentage, if we asked her what's her percentage of passing an exam, what would be her percentage of passing any exam we throw her way? Somebody else.
80%.
80%, right? So she has an 80% chance of passing exam. That's just how confident she is, right? Now, I specifically asked about probabilities, right? So what's her probability of passing an exam? Uh-oh. This can't be the stumper.
Is it 0.8?
The only thing wrong with that is it was in the form of a question. Yes, it is 0.8, right? So 0.80, right? Now, the reason why this is important is because remember I told you how we had those kind of graphs with the different colored binomial probability distributions, and there's different binomial probability distributions for each number of times you can take the exam, right? Like 2 times, 3 times, or 5 times, right? There's also different binomial probabilities for the probability that Jasmine had. Jasmine, if I throw any exam her way, no matter what it is, it could be rocket science. There's a 50% chance that she will pass that exam, right? So there's also different binomial probability distributions based on the probability of passing an exam. So according to what Jasmine just said to us, Jasmine believes that this is the, it went to the wrong place. This is the binomial, this is the probability of success column that we should attend to, because that's where she is. No disrespect to anybody else. There's other people in this room who might be like, oh, hell no, Jasmine ain't nothing. I'm a 99% chance of passing. So we would have to look for you, because that's what you believe, down this column, right? And or if you were to say you're a 60% chance of, we will look at this column, because that's what we believe. We're going to assume that Jasmine knows her inner self very well, right? That's what we believe her probability of being successful on any Cheney exam that's been thrown her way in the last couple of years of her passing it, right? I'm not saying she's right or wrong, but let me tell you what this binomial probability distribution allows us to do, right? So Jasmine says there's an 80% chance for her to pass any exam that you ever throw her way. And our math exam allows us to, allows you to take the exam 5 times, right? So we'll be looking down here because the number of times we can take the exam are 5. She thinks that she's an 80% ability to pass, right? But here's the thing. I can look in D2L and see how she did on the 5 attempts, right? Now, on the 5 attempts, Jasmine only passed one of them. Now, this is hypothetical. I'm not calling her out, right? She only passed 1 out of the 5 times. So this is the question that a binomial probability distribution allows us to ask, right? What is the probability that Jasmine, who, according to her, will pass 80% of the exams that come her way, right? What is the probability that on her 5 attempts, she would only pass one of them? It is a 0.006 probability of that happening, right? So this is what would happen. Now, imagine Jasmine took all 5 math exams. She only passed 1. And the probability, according to this, is that it's a 0.006 chance. You know what I would probably conclude? That's a real low probability of that occurring. As a result, I don't think you're right. I don't think you really do have an 80% probability of passing any exam that we pass your way, because the chances of you having an 80% chance of passing any exam and you only passing one of them, that's super low. I ain't gonna bet no money on that. So I'm going to reject your claim that you can pass 80% of those exams, right? But let's go do another one. This is still, I'm gonna use the other Jasmine, right? Because I don't want Jasmine to think I'm coming at her, right? So this is Jasmine Mays. Jasmine Mays said that she also can pass 80% of her exams. But when she took 5 of them, she passed 4 of them. She passed 4 of the possible attempts on her math exam. Now, this table was showing me that, okay, you got 5 attempts. She took it 5 times. How many times did she pass the exam, right? She passed it 4 times, right? So there is a 0.41 probability of that happening. That's 41% chance. That's not low. So I'm not going to argue with Jasmine Mays. Like, you know what? Hey, that's very likely. There's a 40% chance of what you just talked about could occur. So maybe you're right. Maybe you can pass 80% of all exams passed your way. That's the Dr. Barnes version of how to use the binomial probability distributions. Let me ask you this now, Reese, does that help?
Yes, it did.
All right, anybody else? Does that kind of help, but now you confuse in a different way? Speak now, forever hold your peace. See, I keep saying that. That's scary moment. That's actually a deep context. And honestly, I'll tell you, I don't think the textbook went into detail like that visually. And honestly, I don't think I've ever went into detail like that to try to explain it. So like I said, these uncomfortable moments, which y'all have to make me be your teacher, are actually good. Oh, I didn't realize this. My camera's not on. My bad. Great question. Now, with that said, unless anybody has any additional questions, I'm going to move on to
Dr.
6.1. All right, go ahead, Wisdom.
I'm sorry, but yeah, I had a question for the quiz too. For like finding the significant number, I had trouble for the 8 children one.
All right, so let's look at what this, and I think I'm going to do this by going back to the same chart that we have, right? Because this table I mentioned before, it's it only goes up to 8, right? But we can use this table to help us, right? So this is frustrating. Let me see. Let me copy this. You can do me a favor to help me speed this up. The only thing I would ask anybody to do is to let me know what question you are actually talking about for the homework on 5.2. I'm going to find it regardless.
No, Dr. Barnes, the 5.1 quiz.
Oh, it's the 5.1 quiz. All right, so wrong chapter, my bad. So when you talk about the quiz, are you talking about the math exam quiz that I created?
Yes.
Okay, all right. So let's go back to that. We'll do it. Now, here's a question. Are you okay with me showing the class one of your attempts on the math quiz?
I mean, yeah, that's fine. I only took one because I'm too nervous. I was too nervous.
Okay. And you know what? I hear what you said, and I want you guys to kind of get that nervousness out of your system. I talked to a student before who did it. I'm telling y'all need to make me teach you, right? That is the job. That is what my salary is based on, right? So what you need to do is, if you take the quiz and you're confused, ask this question. Ask this question. Now we can do it during class because I want to give this kind of walkthrough, but this can just be a one-on-one jump in. You don't understand what's going on, whatever. But this is the kind of help that you guys need. And trust me, if I can sit back and do what I just did with Nyrese with unplanning, I think I can pretty much do anything in this class, even though I might be nervous. But let me tell y'all, to be honest, y'all probably don't know when I'm sweating or I'm nervous or I'm freaking out. So make me uncomfortable. It makes me better. And the same thing goes for you. When you get uncomfortable, that is when it makes you better. All right, so is this the question that you're talking about right here? Which of the following number of girls is considered a significant number of girls out of 8 children?
Yes.
Okay, now I want to show you guys something. Uh-oh, what happened? Oh, it's a quiz, I'm sorry. Great attempt. Probability of having girls out of 8 children. Now, you know what? This doesn't tell you what the probability is, but I want you guys to remember this first digit of 0.004, 0.031. I'm going to do this as well. If we go to this binomial probability distribution table that we were looking at over here for 8 children, those values should be, they are right here, 0.004, 0.0031. So let me tell you what this is saying. This is giving us the probability of having girls, which is a success, on 8 attempts, like you're trying to be Octomom, right? And they're saying that since these numbers match, the probability of having a girl assumed in this problem is 0.50, because that's the probability that we have up there. So that's the reason why we're looking at that. So the binomial probability distribution is that, and it's completely different. If somebody said the probability of having a girl is a little bit higher than 0.5%, which it actually is. I think it's about 0.56 probability of getting a girl. If you have a child, we don't have that distribution here, but we would probably be more inclined to use this distribution, right? And this distribution is very different. Let's look at how these differ, even though they're right next to each other. So the one that we're looking at right here is, this is the, I'm going to text this in. This is 0.5. P equal 0.5, y'all can see that. And then the other one I'm doing is P equal 0.6. Right, and then I'm going to draw a little line in here to separate these two. So this is our heading, and this is how we just look at those two tables, right? Again, the same way which I was kind of talking to Nyrese. We are asking, all right, what number of having girls out of 8 would be significant? Now, guys, what is that magic number that we use to determine whether something is significant?
Isn't it 5%?
5%, all right? Now, we're gonna do the same thing like we did before, right? She said 5%, right? But whether I said it or not, I'm actually looking for a probability. So not you, I think that was Goodman. Somebody help me put that 5% into a probability. What probability must it be less than?
0.05.
0.05. That's what y'all be saying, to be throwing me sometimes. Same thing, right? So in order to find out what number of children, right, are significant, is a significant outcome, we got to look at the distribution for 0.5, which is what I gave you. Let's look at this. If you were to have 8 children, you were Octomom, right? And you had 0 girls, the probability of that is 0.005, right? Let's do this. 0.004, I'm sorry, is less than 0.05. So that is significant. So when we look on that chart, we definitely should pick 0. Having 8 children and getting 0 girls, that's significant. Let's look at the next one. The probability of getting 1 girl, right, is 0.03. Now, what two numbers are we going to compare here? Don't be scared. The only real wrong answer is no answer. Above for the first one, we compared 0.004 to 0.05. If we're looking at the probability of having 1 child, what two numbers are we comparing?
Wouldn't it be 0.031 is, and then yeah.
Right, we're comparing it, and somebody else other than Siani, I believe, is that number less than or greater than? .031, is that less than or greater than?
Greater than.
All right, so now that's great. I'm not going to knock you for trying, but we got to think about what we're referring to. We're referring to the 0.031, right? 0.031 actually is less than 0.05. And again, I mean, it happens, trust me. All right, so let's move on to the next one, right? The next one is we're going to be comparing 0.109. Oh, hold on, didn't show up. 0.109 to 0.05, right? Now this one, whoever said that it's greater than last time, jump in, because now when you say the same exact word, it's going to be right. So is 0.109 greater than or less than 0.05?
Greater than.
All right, okay, greater than, right? So that means it's not significant. Right? Now, we can do that for every last one of these. All we're doing is we're in our mind comparing, this number. 0.219 is definitely greater than 0.05. 0.731 is definitely greater than that. Now look at this. I want y'all to realize that since this distribution, it gets to the high point, now it's being symmetrical. This 0.219 is the exact same value as this. The 0.109 is the same as that, and the 0.31. So here's the issue. We already know that the probability of getting 0 and 1 are significant. And since it's symmetrical, these two also. So the values that you need to pick for that quiz, I'm going to clear all this. When I'm asking you, all right, hold on. When it's asking you which of the following number of girls is considered a significant number of girls out of 8 children, which ones would we pick? Now, again, we all up in wisdom's attempt, but which ones should we really pick? And actually, if you look at this from my viewpoint, the real answers are actually on here. So which answers should she have checked?
Can you show the chart? Can you show the chart? Can you show the chart?
Yes. Oh, my, you're right. You're right. My bad.
Would it be 0, 1, and 7 and 8?
0, 1, 7, and 8. And that would have been significant. And I think that can, at least I hope, I think the way we got into this right now is probably a more complete way for y'all to understand it. But I also just want to say back and show y'all how, yeah, it really was the same thing. That distribution from this table right here, that I just pulled one slice of that table out and gave it to you right here. And that's because those requirements are the same. Fixed number of fixed number of children, and then we're asking what's the probability of getting a certain number out of it. So with that same logic, the next couple of questions are which ones are significantly low number of children and which one's a significantly high number of children. So of course you would go to the 0, 1 half, and then you would go to the 7, 8 half for the high number. Same thing, basic teaching of, the basic concept from this. All right, anything else you have? Or anybody else the whole class? We'll just share the love a little bit.
Can you say that whatever you said about it being significantly high again?
Okay, now right here, when we're talking about a significantly low number of girls, right? Since we're talking about a significantly low number of girls, then we're only going to be attending to this end of the spectrum. So for this question right now, when it says which number of girls is considered significantly low, you would only do 0 and you would only do 1. Now, if we sit back and say which number of girls is considered a significantly high number of girls, we would look here because this is less than 0.05 and this is less than 0.05. So it will be 7 and it would be 8. And again, that's the reason why I think this is a very important critical thinking exercise, why you have 5 attempts to take it. That's why you can come and talk to me afterwards to get it. But this is something that's really key. And I'm glad, it's a great question. It's a great question. Anybody else before we move on or in this same quiz? All right. No, I'm joking with y'all, but like I said, keep these hard questions coming. Keep these hard questions coming because this is what y'all need to learn. And like I said, what Naris asked beforehand, I'll be honest, sometimes when following reading, following examples on PowerPoint, I don't think I ever got into explaining the binomial probability distribution from the chart, which real talk, I actually think might be one of the best ways to actually do it. Any other question before we move on to 9.1?
Yes, I have one, sorry.
Okay.
For the binomial probability formula, I'm confused as to like what the exclamation point, like what that stands for, I guess. Not necessarily what
It's
it
the
stands for, but what.
factorial.
All right, and you know what? I want to sit back and I'm gonna remind y'all again. Let me tell you, no Essence Frazier.
No problem. Sorry.
Esther
I didn't mean to cut
Frazier.
you off, but it's the factorial.
No need to apologize here. We're all out here trying to help, right? So let's go to stats 2. And I'm going to go down to the essence of statistics. Here's a video that's in here that has been created for you guys. That if you go here looking for this stuff, it'd be very helpful. And me and Essence, through a period of 2 weeks, we worked on something that I think will make it so that if you watch this video, nobody, in my mind, should be confused about what a factorial is. So I'm going to play it right now. I'm going to do it at 1.25 speed, just so we can go. If it's too fast, I'll slow it down. All right. What is a factorial? Great question, Naris. Here's the answer.
Hey, everybody. My name is Essence, and this is the Essence of Statistics, and today we'll be having a tutorial about factorials. So you may be asking yourself, what is a factorial? A factorial is the product of all positive integers equal to and less than a given positive integer, denoted by that integer, and then followed by an exclamation point.
Followed by an exclamation point, right? Now, the product means multiplication of all possible integers equal to and less than a given positive integer, right?
So there are 2 main ways that you may see a factorial listed in your textbook. The first way is by having a positive whole number followed by an exclamation point, and the second way is another positive whole number followed by the word factorial. Now, by using the number 8 as our example, you can see the 2 different ways that you may see the factorial listed in your textbooks.
All right, so again, that's just going back, letting you guys see when you see that exclamation mark, which is exactly what Naris was like, what? This is what you might look at. Some
Dr. Barnes,
go ahead.
can I try to explain what that means? So I can like help myself understand it too. When she says the number equal to and less than the product of those numbers.
Yes, you can.
So
How about you do it for 9?
Okay, so it would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right?
Yep. Exactly. Now I know.
Why don't we times it by 0?
Just because if anything you times by 0 will be
0, right?
Would be 0. But the real answer to that question is, what does a factorial represent, right? And we didn't get into that in this video just yet, right? But a factorial is representing how many ways you can arrange something, right? So imagine I got my son's pick right here. I'm not sure if y'all can see my camera. I got one pick, right? How many ways can I arrange this pick, right? One pick, I can only arrange it one way. Travis, give me your cell phone.
Huh?
Give me your cell phone.
Why?
Now, the next question is this. I now have two cell phones, right? You can tell this cell phone, that cell phone. How many ways can I arrange this cell phone, right? A factorial will allow us to do that. I can either have this cell phone first, followed by this, or let's switch it up, right? We can have this cell phone first, followed by the next one, right? So that's what a factorial is doing. It's saying how many objects you have, what are the unique ways that you can rearrange them, right? So the reason why we don't multiply it by a 0 is because one of the spirit of what a factorial is, but if you add 0 to it, it would be 0. Anything times 0 is 0.
I have one more question. I feel like it's a dumb question, but
Ain't no
if
such
I
thing.
were if I were to do 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9, would it give me the same answer?
Yes, it would. Yes, it would.
Okay. All right. I thought it would. I was making sure.
Okay. All right, I'm going to continue on. We're going to skip that slide since Jasmine helped us.
Now let's do another example using letters. How many ways can a person draw 3 letters from a bag of only 3 letters? And let those 3 letters be A, B, and C. Again, by using factorials, we just need to multiply 3 times 2 times 1. That gives us a final product of 6. Here at the bottom of your screen, you can see the 6 different ways that we can rearrange the 3 letters without repeating. Now you may be wondering, how do I calculate 0 factorial? Well, since there is only one way to rearrange nothing, 0 factorial is equal to 1. In our other example, imagine it like this. How many ways can a person draw 0 letters from a bag of only 0 letters? Only one way. Lastly, what about negative numbers? We have to remember back to our definition that we had on the second slide. Factorials deal with positive integers. You cannot have a negative integer factorial because they would be undefined. I hope this helps. Now you know more about factorials and how to calculate them. See you in my next video. Bye.
All right. Essentially, I like that question. That's almost like saying if I have $0, how many ways can I arrange $0? You don't have no money, so you can't arrange it in any type of way. That's what it is. But again, like I said that video and we watched that video just to let you guys know the essence of statistics is there. One of the things that is in essence of statistics that is really helpful for all of you, I would imagine, are kind of the answers to the problems. Now, this is what, if we just did 5.1. So let me go. Stats to, let's go down to 5.1. Now, one of the questions that Wisdom had was how to do one of the things on homework 5.1. Now, we're not collecting homework or making you do math exams, but you really should still do the problems, right? Now, if you're getting stuck on anything on the math exams that we're doing, chances are these math exams are very consistent with the homework problems. So what we did right here is these are some mock problems. When you read the ones before, this is talking about the number of boys in 4 births. If you go look at the homework, it might have been the number of girls in 8 births, right? Now, in addition to showing these fake problems that we created that you can practice with, right? We also have those same fake problems with answers. I know there's one person in the class who's using them. He's being like, Dr. Barnes, hurry up. I need him. I need him. We're probably a little bit behind, but that's how it happens. This is like a very, what do you call it? This is an additional resource to help people, right? But in red for this problem right here, it tells you and gives you an explanation on how to solve that problem and the rationale and thinking behind it. This is asking what is the random variable and what are the possible values and are its values numerical. Reading this, the random variable is X, which represents the number of boys. If you pay attention, you can see that, okay, X is right here, number of boys. The possible values of X are 0, 1, 2, 3, and 4, right? And the values of the random variable are numerical. Why? Because 0, 1, 2, 3, 4 are there. So if you're struggling with any of the homework problems that you guys are assigned to, I would definitely go in and look at Essence of Statistics because we have resources in there that are designed to help you. It comes from the easy to the complex. Right now, somebody might be telling me that they don't know how to calculate the mean from a probability distribution. This right here is her doing it. you must multiply or calculate the sum of the random variable times the probability. This is showing how you do it. 0 times 0.071, 0 times 0.071, 1 times 0.428, that's right here. And then at the very bottom, she totaled those up and got a value of 2.04, right? This information is here to help you guys. And I think it's a, since I know she's working really hard to sit back and get this up and running, we're probably a little bit behind, right? So if anyone's working ahead of time, don't even reach out to me. But anybody who's might be meeting the deadline, it might not be there. But remember, every math exam that you have, right? You have an extra week. So with that being said, me and Essence do know the schedule. It is difficult to kind of create these from you. I don't want to just put them up so it's cheating her learning experience of what she's doing. And I just wouldn't even do it. I just wouldn't go this deep to help y'all, no offense. So we might be a little bit behind, but look here, always look, continually look, because since we're creating them in real time, it might not be there Tuesday, but it might be there Tuesday at 9 p.m. That's just how much we're updating this stuff. And the closer you get to the homework assignments, the more likely that information will be there for you. I feel like that's a little tangent. I feel like somebody wasn't able to answer maybe the next question that they wanted, but I just want y'all to really see the resources that we're creating. Because if you're not comfortable sorting, using, looking, and asking questions, let me tell you, this class is going to be 7 times harder than it needs to be, because you sit with the screen right now. One of these windows right next to you that you don't want to talk to, you don't hang out with, or you don't want to learn with, that next window in this room is using the essence of statistics, is using me, is using my office hours, is using emails to get them help. They're not as stressed as you. And real talk, I got to say, whose fault is that? I don't know. So again, with that being said, I think that's it for class. We got 50 minutes. I hope I was helpful. I will see you guys Friday. See you guys Friday. All right, I'm gonna stop recording.